Hello students, in this video I am going to demonstrate you an activity based on the central limit theorem using Excel. So firstly what we need to do in this case, if you have a large data, then you can perform that activity on that particular data only. But in this case, although I have a large data, but if you don't have a data and you want to practice this particular activity, then you can generate your own data also. Okay, in our last video based on the activity of normal distribution, I told you that how can we generate a data based on any specific distribution. So if you want to generate a data, then you can click on this option of data and then click on the data analysis toolpack, and then there is a option of random data generation. Then you can use this particular option, and with the help of this option you can generate different kind of the data that either you want to generate a data based on the specific distribution like uniform distribution, normal distribution, Bernoulli distribution, Poisson distribution, binomial distribution, or discrete, any other discrete distribution. Then you can refer this command, right? Or otherwise there is a reg command of generating the random variable or random number also. So in that case you can use the command of random number or random number between. For example, in this case I'm going to use the command of say random between. So random between, suppose I'm considering here a data which is based on, you can say that the CGP of the student. We know that the CGP of the student is falls between 0 to 10. So suppose that I'm giving the minimum value as a 0 and the maximum value as a 10 only. So basically I'm generating a discrete data. Okay, so because the first condition for the central limit theorem is the sample size should be large. So what I am going to do in this particular activity, firstly I just give you a brief idea about that. Central limit theorem states that the average distribution tends to normal distribution if the sample size is large. So in this case specifically I am going for x bar minus mu upon sigma upon square root of n. It will follow normal distribution with mean 0 and variance 1 as n tends to infinity. So in this case we are going to consider our random variable as a x bar only. That is, in this case I want to generate a sample based on sample mean x bar. Okay, so for that firstly what we need to do, we need to firstly generate a large data, and then with the help of that data we need to generate different samples, and then we need to find out their sample mean also. Let me demonstrate you. So suppose firstly I am going to generate a random sample of say about 1000 observations. So I simply drag this value down. So suppose I am generating here data of say 1500 observations. So this is a random data I have generated here whose value is between 1 to 10. So but because here I have used the command of random data only, so because every time when I am going to refresh the data, then the value of the data will change. So I am copying this data and I am pasting it next column only. So but here I am using the option of paste values, because if I use the formula then again every time the value will get changed. So I am using this formula of values only, and now because this data is of no use, so I am going to delete this data. So this is my actual data now. So let me delete this column so that this data is shift to the column A only. Okay, now the next step is, based on this particular data I am going to generate a sample. Okay, suppose I want to generate about say 500 samples. So I am saying this is sample 1, sample 2, and so on. I want to generate say 500 samples with the help of this particular data only. So I simply drag it to the right hand side so that we know the count of 500 samples here. Okay, so now we have about 500 samples. So now how can we generate a sample here? So to generate a sample, I'm going to use the command of index here, index. So what is the input here? The input is the firstly array, control shift down, so I have selected the entire data. The next step is I want to select the row number because I want to generate a random data. Okay, so here I am going to use the command of random between uh, 1 to 1 to the count of 0 from A1 to A1 1500, right? That means I am going to select the complete data here. Okay, and because here we have only one column, so I am going to select this data. Basically, what is the purpose of this particular command here? So suppose that we are having a matrix. Okay, we have a matrix and I want to get any specific value from this particular matrix, say A23. So how do I get this particular value? So the command is index. Firstly, I need to give the array. Array means I am going to give the idea about the given matrix. So in this case, I firstly select the array. Array is the given matrix. The next step is, because I want to get this particular element which falls in a second row. So the second thing, I need to specify the number of row, and the next I need to specify the number of column here. So it will give me this command will give me this particular element A23. Okay, so but in this particular case we are having only one column, so that's the reason the last value is 1 only. But row, because I want to generate a random data, so I will use here the command for row as a random between any one of the element from these 1500 entries. And because it is a column matrix only, so here we have only one column, A1 to A1500. Okay, so this is the purpose of this command. So now after getting this particular command, so we'll get one value. Now I'm going to drag this formula to the right hand side to 500 observations. So we can get and now, okay, let me see. Okay, so basically I haven't added, because this data falls in a first column only. So if I want to drag this formula, I need to firstly insert the dollar sign. That means I need to fix this particular, that means I am going to select this data from this column only. Okay, so there is a shortcut key to put a dollar sign everywhere is function key F4. So with this command we simply add a dollar sign everywhere. Here one dollar sign, in the earlier activity we are using only one dollar sign because we are fixing column only. But when I add this dollar sign in front of number, it means I fix the column number. And if I add this dollar sign in front of alphabet also, it means I fix this row. That means I actually fix this entire cell only, right? Now if we drag it in the right hand side, then you will find out here you will get the different numbers also. Okay, so now I need to drag this formula to the right hand side to generate a sample of 500 observations. Okay, so now the next step is I want to this is the first entry of 500 samples. So suppose that I am expecting 500 samples with each sample containing around say 1000 observation. Okay, so I can simply extend this particular formula up to 1000 observations. So I am choosing the large sample because I am going to use the central limit theorem. It states that the distribution follow normal if the sample size is large, right? Okay, so because I have generated a large sample, so it may take some time to generate this data. Okay, so till then I'll just tell you that what I'm expecting here. So basically I have generated 500 samples. So the next step is I need to find out the sample mean of all these samples, that is x1 bar, x2 bar, x3 bar, so on up to x of 500 bar. So if we'll get this sample of 500 means, right, then we need to apply the normal distribution activity on this particular sample only, right? Like in our last video of the normal distribution, we are having a sample, okay, where we are considering that particular sample as x only, but now in this case our x is replaced with x bar, okay, and we have to perform this activity on sample mean only, and I want to prove that this sample mean having the mean, that is the mean of the sample mean, it will be mu, and the variance of the sample mean, that will be equal to sigma square upon n, okay, and this x bar will follow normal distribution with mean mu and standard deviation sigma upon square root of n. This I want to prove in this particular activity part, okay. So now this data has been generated. So the next step is what we need to do, like we did earlier. I'm simply going to copy this data and paste it in a new sheet, because here we have used the command of random data generation. So every time when I'm going to refresh this, then the data will get changed. So I'm going to paste this data as a value only. This is the most important step whenever you are performing any activity based on the random data. So when you first step is always copy this data and paste it as a value only, so that it will remain as a number only. Because if you just look at in the previous sheet, if I select any one of the observation, then it will not give you the number, it will give you the formula only. But now if I select any one of the cell, it will give you the value only, right? So let us consider this as a data 1, data 2. So now we have about 500 data, right? So which we have generated using the command of random. So the next step is we are going to find out the mean of all these samples, okay. So again I'm going to use the command of calculating the mean. So the command for mean is okay. So let us calculate the mean of all these samples. So let me go to the very first sample here, and that I'm using the command average. So this is A2 to A1000. So basically we have about 999 count of this data. Okay, so we will find out here. Now these values are in a decimal place, like in the last activity we have generated a data where the values are in a approximate decimal form. So now we get these 500 samples observation as a sample mean only. So now the next step is I'm going to copy this data again, and then I'm going to paste it in a new file, but this time I'm going to use the command for paste as Ctrl plus Alt plus V. Here I'm using the command for pasting the data as Ctrl plus alt plus V. So when I use this command, then you will get this kind of window here. So I need to select two options, firstly values, and second I need to take the transpose of the data, because the data is in the row form, but I am expecting here data in the column format only, right? So when I click OK, then this data is generated here. Okay, now let me label this data as a mean. Okay, so to analyze this data, so the first step is, so it is similar to the normal distribution activity. The first step is I am going to perform the descriptive statistics of this data. So I have selected the option of descriptive statistics, click OK. Here the input range is the data, control shift down, and then where I want to see the output, I want to see the output of this data in a very next column only. So till the data get generated for the descriptive statistics. So firstly we need to get the descriptive statistics of the data, so that we can analyze this data, because for the analysis purpose I want to draw the histogram or the line graph of this curve. So I should know, I need to firstly construct the bin of the data, right? So for that I need to know that what is the minimum value and what is the maximum value of this data, right? What is the range of the data. So for that particular purpose we are performing this descriptive statistics. So what I want to see the output, I want to see the summary statistics. Okay, so now I click OK. So although if we just look at all these observations, then the value is nearby about 5.5 only, but let us see that what is the mean, standard deviation, minimum value, maximum value. Like with the help of this descriptive statistics we can get all these basic information about the data. So to perform the analysis after getting this data of this sample mean, so here we get the sample mean. So after getting this sample mean data, so how many samples we have, this sample mean is, the count is say n, right? So what I need to do to perform the analysis of this data, firstly I need to look at the descriptive statistics, that what is the minimum value, what is the maximum value of this data. So we get the descriptive statistics of the data. So we find out here that the mean of this data is around 5.467, and the minimum value of the data is 5.15, and the maximum value of the data is 5.709, and the range of the data is 0.55255, and the count of this data is 500 only. Okay, so because the sample is of we have 500 different samples, and this is the mean of 500 samples only, so it means that the count is 500. So what is the next step? The next step is we need to construct a bin. And what is the bin? bin we need to construct like in the normal distribution activity, that we are expecting about 10 to 20 partition of the data. So but in this case the range is 0.55 only. So if I'm suppose I'm expecting around 11 partition, then we can choose the value as 0.1. okay, so the minimum value is 5.15. so suppose that I'm starting from 5.1. I'm taking the bin size as 0.1. so plus 0.1. okay, so it means that I'm taking 11 partitions, so we'll get about 12 intervals, right? So that it will cover the minimum value and the maximum value also. So we have started from 5.1 because the minimum value is 5.15 and the maximum value is 5.70, so we need to go up to 5.71. okay, 0.01, sorry, we need to take 5.01. so I need to start it from 5.14. let's say okay, I need to start it from the minimum value, say 5.15, and I need to add 0.01. okay, if I am expecting, wait, let me open the calculator. So here the range is 0.055, 0.55. So if I am expecting at least say 10 partition, so its value is 0.055. okay, so if I am expecting about say 15 partitions, so I need to choose a value as 0.036. so let us choose 0.05 instead of that. So let me change the formula as 0.05. So we need to consider formula up to 5.75. so how many partitions we have is around 13 partitions we have. Now the next step is we need to find out the frequency. okay, so one most important thing is that how you are going to decide the bin value. okay, so for bin value you need to know what is the minimum value, what is the maximum value. Basically you need to find out the cover of this entire interval, minimum to maximum, and you need to take at least 10 to 20 partitions of the data. So accordingly you simply to find out the range of the data and divide it with the number of partitions. That will give you the width between the two consecutive points. okay, so the next step is we need to find out the frequency of the data. For that we go to the option of data analysis and then we select the option of histogram. So here we need, so firstly the input range is the given data of means, control shift down. The next step is we need to select the bin range. Bin range is this bin value, control shift down, and what I want to see the output. So I want to see the output range in the very next column, say here only, and then click OK. So we get the frequency of the data. Now the next step is I want to find out the probability of this data. Direct probability using the formula of the proportion here. So firstly I am going to calculate the sum. So the sum should be 500. It is equal to the total number of observation in the sample mean data. Okay, now to find out the probability of this data, let it be denoted by P of x. So the command is frequency divided by the total sum of the frequency, which is 500 only. So here I am using a dollar sign because I want to fix this particular cell of this column. So now I drag this formula to get all the probability. So simply double click on that particular dot, so you will get all the probabilities here. And if I extend this formula of sum, then the total sum of the probability should be equal to 1. Now the next step is I want to calculate the probability using the normal distribution only. So let this is denoted by f of x. So the formula of the normal distribution, like which we already discussed with you in the normal distribution activity, that in this case I need to find out the probability at a point because it is a discrete distribution. Then I need to add a continuity correction to convert this discrete data into the continuous one. So we need to convert probability x equal to a as a minus delta to a plus delta. Okay, and what is delta? Delta is equal to the width between the two consecutive points divided by 2. Like if you just look at this data, in this case the width between the two consecutive points is 0.05. So if it is 0.05 divided by 2, so it is 0.025. This is the continuity correction here. Okay, so it means that how do we calculate the probability? It is upper limit minus lower limit, x is less than a minus delta. So we need to use this formula. So if I use the formula to calculate the probability using normal distribution, so firstly I am going to click the command on normal distribution. The first step is I need to input x. What is our x? X is the bin value plus the continuity correction. Continuity correction is 0.025. And what is the mean value? This is the mean value. Then the standard deviation, this is the standard deviation of the data. And we need to calculate the cumulative distribution function here. One more important thing, we need to put here a dollar sign because we are going to consider the same value of mean and standard deviation throughout this probability. So this is the probability of the upper limit. Then minus, we need to calculate the probability of lower limit also. So in the lower limit we need to subtract this continuity correction. Okay, so I am using the formula probability x is less than a plus delta to x is less than a minus delta, upper limit minus lower limit. And because I need to calculate the normal distribution probability, so I need to input the mean and the standard deviation also. So this is the formula for calculating the probability. So we'll get this probability here. Now I am going to drag this formula to get all other probabilities also. And also if I drag the formula of sum, then the total sum of the frequency should be nearby 1. It is 0.999. Okay, so the next step is I want to see the nature of this curve. So I'm going to draw the plot of this data. So I can use the command of insert and then recommended chart, and here I can choose the option of the line graph. So you can see here the graph is approximately normal only, right? Although both the graphs are very much close to each other. So this orange graphs represent the actual normal distribution curve f of x, and p of x is the approximate probability which we have calculated here. Okay, like I told you that this particular distribution x bar follow normal distribution if we want to verify the result. So for that, what can I do? I can simply pick up the actual data which we have considered for this same. So this is the actual data. Control shift down, Control C. Let me paste it here. Okay, so this is the data we have. Control V, Control C and Control V. Now because as per the central limit theorem, I need to know the average of this data and the population standard deviation, right? If I calculate the average of this data, it is 5.4633. this is the mean of the data. And if I calculate the standard deviation of the population, right? So this is equal to, because I have drawn this sample for all the 500 sample from this particular data, means I am assuming this as a population. Okay, so I'm using the command of standard deviation for population, stdev.p. So Control shift down, bracket close. So if I use the formula of standard deviation, its value comes out to be 2.797735, right? So this is the mean of the data and this is the standard deviation. And if we just look at the mean and the standard deviation of the data, this is the mean, and this is the standard deviation of this data. Okay, let us verify that either it satisfies the normal distribution behavior or not. So what it says, the means are approximately same, because if I find out the difference here, the difference of mean, this is equal to this, equal to mean minus you can see here, although its value is approximately same, so the difference is very small. They are almost same only, right? So the next step is here it is 5.46 and it is 5.4633. So the means are approximately same, but the standard deviation of the population is 2.79. Okay, if I calculate to this particular number divided by square root of n. Square root of n means here the sample size is 500. So if I divide it with 500, then its value approximately comes out to be 0.125, and here the standard deviation is 0.089. So its value is approximately 0.09 and its value is approximately 0.125. Okay, so you will find out the difference is very small. Okay, so what it shows that x bar, whose mean expectation of x bar is 5.46 only, and its standard deviation, like square root of variance of x bar, its value is 0.9 approximately. But on the other hand, the mean of the population is 5.467, and the standard deviation, that is sigma upon square root of n, its value is 0.125. So you will find out the difference is very small. So it clearly shows this particular thing in this particular graph. Okay, so the only thing is this graph is slightly deviate toward the right hand side. So if we take a more large sample, because we have taken a sample of size 500 only, if we increase the sample size, then these two curves are more closer to each other. Okay, so this is the interpretation of the central limit theorem, and we have performed this activity with the help of this data. I hope you understand this concept of central limit theorem activity. If you are still having any doubt, so you can post your query here. I'll try to provide you the solution. Thank you and have a nice day.